Proxima Centauri is the closest star to the Sun, just 4.24 light-years away, and it is part of the Alpha Centauri system, the nearest stellar system to our own. Proxima is a small red dwarf, only about 1/8 the mass of the Sun, and it is so faint that despite being our nearest stellar neighbor, it cannot be seen with the naked eye. It is also an active flare star, meaning its brightness can suddenly increase because of powerful stellar eruptions. What makes Proxima Centauri especially interesting is that it is not alone. At least 2 planets are currently confirmed around the star, Proxima b and Proxima d, while Proxima c has been proposed as a longer period planet candidate, but is not currently listed as confirmed by NASA's Exoplanet Archive. This means that the nearest star beyond our Sun is also home to a small planetary system, making it one of the most interesting places to study when astronomers look for worlds outside our solar system. The most famous of these worlds is Proxima b. It was discovered in 2016 using the radial velocity method, which does not directly photograph the planet. Instead, astronomers measure tiny changes in the motion of Proxima Centauri caused by the planet's gravity. As Proxima b orbits its star, the star moves back and forth by a very small amount. Detecting that motion allowed astronomers to infer the planet's presence, even though the planet is billions of times too faint and too close to its star to simply photograph with an ordinary telescope. Proxima b is particularly interesting because it has a mass of roughly 1.06 times Earth's mass and completes an orbit around its star in only 11.2 days. Its orbital distance is about 0.049 astronomical units, meaning it is incredibly close to Proxima Centauri compared with Earth's distance from the Sun. Yet because Proxima Centauri is a much smaller and cooler red dwarf than our Sun, that close orbit places Proxima b within the star's habitable zone. This is the region around a star where temperatures could, under suitable atmospheric conditions, allow liquid water to exist on a planet's surface. But the word habitable needs to be treated carefully. Being in the habitable zone does not mean that Proxima b has oceans, an atmosphere, or life. Scientists have not yet confirmed any of those things. The planet's environment could be radically different from Earth's, and one important complication comes from the star itself. Proxima Centauri is an active red dwarf that frequently produces powerful flares. These eruptions can release intense radiation and high-energy particles, potentially affecting the atmosphere and surface environment of nearby planets. NASA has specifically highlighted the star's frequent and potentially damaging flares when discussing the conditions around Proxima b. Proxima b is also expected to be tidally locked, meaning the same side of the planet may permanently face Proxima Centauri, while the opposite side remains turned away from the star. NASA's current educational material uses this model for Proxima b, describing a permanent day side and night side, with a region near the boundary between them experiencing constant twilight. If Proxima b has a suitable atmosphere, heat could potentially be redistributed between these regions, but the actual climate remains unknown because we do not yet know the planet's atmospheric composition and structure. The fact that Proxima b orbits so close to its star also changes how its sky might appear. Proxima Centauri would dominate the planet's local sky, appearing much larger and brighter than the Sun appears from Earth, while the distant Alpha Centauri A and B would remain extremely far away across the surrounding stellar system. But from Proxima b, the star would not rise and set in the familiar way Earth experiences with the Sun. If the planet is indeed tidally locked, Proxima Centauri would remain fixed over one region of the planet's surface. Then there is Proxima d, a much smaller world that orbits even closer to the star. NASA classifies Proxima d as a terrestrial exoplanet with a mass of only about 0.26 times Earth's mass, or roughly a quarter of our planet's mass. It completes one orbit in just 5.1 days, at a distance of about 0.029 astronomical units. Its discovery was announced in 2025, making it a much more recent addition to our knowledge of the system. Proxima d is interesting for another reason. It demonstrates just how small a planet astronomers can detect around a distant star. The discovery relied on extremely precise measurements of Proxima Centauri's motion. The gravitational pull of a planet as small as Proxima d creates only a tiny change in the star's velocity, so detecting it requires instruments capable of measuring variations of just a few meters per second. The planet itself is far too distant for us to see directly with current telescopes. Farther from Proxima Centauri is Proxima c, a much more uncertain object. It has been proposed as a planet with a much longer orbital period of roughly 5 years. Unlike Proxima b and d, however, Proxima c remains a candidate rather than a confirmed planet in current NASA exoplanet archive data. This distinction is important because astronomy is often about separating intriguing signals from discoveries that can be independently confirmed. A promising detection can be revised or rejected when additional observations become available. The star itself is unusual compared with our Sun. Proxima Centauri is a red dwarf, a type of star that is smaller, cooler, and much less luminous than the Sun. It produces far less visible light, but its activity can be far more disruptive to nearby planets. Red dwarfs can remain active for extremely long periods, and Proxima Centauri is expected to remain on the main sequence for trillions of years. In astronomical terms, that gives it an extraordinarily long lifetime, compared with the roughly 10 billion year lifetime expected for stars like the Sun. Proxima Centauri is also part of something much larger. Roughly 4.37 light-years away are Alpha Centauri A and Alpha Centauri B, two stars that orbit one another and are much more similar to the Sun than Proxima is. Proxima is gravitationally associated with them, forming the nearest stellar system to our own. From Earth, the three stars appear close together in the sky, but the actual distances between them are enormous on a human scale. NASA describes Alpha Centauri as a triple star system consisting of the two Sun-like stars and the faint red dwarf Proxima Centauri. Alpha Centauri A and B are especially interesting because astronomers have been searching for planets around them as well. In 2025, NASA reported strong evidence from the James Webb Space Telescope for a giant planet candidate orbiting Alpha Centauri A. It is important to call this a candidate rather than a confirmed planet, because additional observations are required before scientists can establish its existence with greater confidence. If confirmed, it would make our nearest stellar neighborhood even more remarkable, with multiple stars and multiple possible planetary systems within only a few light-years of Earth. The existence of planets around Proxima Centauri also changes how we think about our place in the galaxy. For a long time, the planets of our solar system were the only planetary system we knew. Today, astronomers have confirmed thousands of exoplanets, and the evidence suggests that planets are extremely common around stars. NASA notes that the galaxy likely contains enormous numbers of planets, with many stars hosting their own planetary systems. Proxima Centauri gives us an unusually close example of that much larger cosmic picture. The distance, however, remains extraordinary. Proxima Centauri is only about 4.24 light-years away, which sounds close compared with the size of the galaxy, but it is still roughly 40 trillion kilometers from Earth. Light crosses that distance in just over 4 years. Any signal we send toward the system would take more than 4 years to arrive, and a reply would require another 4 years or more to return. Even our fastest spacecraft would take vastly longer. NASA has compared the distance to Proxima b as being so enormous that conventional travel would take millions of years. This means that when astronomers study Proxima Centauri and its planets, they are doing something remarkable without ever having to travel there. They use tiny changes in starlight, gravitational motion, spectra, and other measurements to reconstruct worlds that cannot yet be directly visited. From those signals, they can estimate planetary masses, orbital periods, distances, and in some cases, the possible conditions on their surfaces. And Proxima b may eventually become one of the most important targets for the next generation of telescopes. Because it is the closest known exoplanet to Earth, astronomers have a much better opportunity to study it than they do most worlds orbiting distant stars. The challenge is that Proxima Centauri itself is extremely bright relative to the planet, and the star's activity makes observations difficult. Separating faint planetary signals from the behavior of the star requires increasingly sophisticated instruments and careful analysis. The discovery of Proxima b also changed the conversation surrounding the search for life beyond Earth. Before its discovery, the closest known potentially habitable worlds were many light-years farther away. Suddenly, astronomers had a planet with roughly Earth's mass in the habitable zone of a star only a little more than 4 light-years away. That does not mean life is present there. It simply means the nearest promising target for studying potentially habitable conditions became much closer. There is still a great deal we do not know. We don't yet know whether Proxima b has an atmosphere. We don't know whether liquid water exists there. We don't know how its atmosphere responds to the frequent stellar flares from Proxima Centauri. We don't know whether Proxima d has an atmosphere or what its surface is like. And Proxima c remains uncertain. Even the planets we have detected are still mostly points of data rather than worlds we can photograph in detail. That may be what makes the system so fascinating. The nearest star beyond the Sun is not simply a distant red dot. Around that tiny star are worlds with their own orbits, environments, and histories, all hidden within a system that is only a little more than 4 light-years away. Proxima Centauri is the closest star to the Sun, but it is also a reminder of how much exists beyond our own planetary neighborhood. The solar system is not an isolated arrangement of planets orbiting one unusual star. Planetary systems appear to be common throughout the galaxy, and some of them begin surprisingly close to home. At this moment, Proxima b is completing another orbit around its star. Proxima d is moving around its much tighter orbit, completing a year in just over 5 Earth days. Proxima Centauri continues producing its powerful stellar flares, while Alpha Centauri A and B continue their own long gravitational dance nearby. All of this is happening only a little more than 4 light-years from Earth. And yet, despite being our nearest neighboring star system, we have barely begun to understand it. The next generation of telescopes may reveal whether these planets possess atmospheres, what their climates are like, and whether any chemistry there could provide clues about the possibility of life. For now, Proxima Centauri remains a nearby system filled with unanswered questions. A small red star with worlds of its own, sitting just beyond the edge of our solar system, and offering one of the closest opportunities we have to study planets around another star. If you enjoyed exploring our nearest neighboring star system, make sure to like the video and subscribe for more space documentaries. And before you leave, take a look at my Neptune documentary on the screen. Just 4.5 billion kilometers from the Sun, Neptune hides the fastest winds in the solar system, enormous storms, and a world far more violent than its peaceful blue appearance suggests. Click on it now and discover what is really happening on the most distant major planet in our solar system.